Okay, today we'll be looking at plots, how to plot stuff in Julia. So, like, possibly, like, yeah, if today, like, I will try to finish, like, installing the plots package and what to say, we will do basic plotting. And what to say, like, yeah, that is basic plotting means I just said about a pie chart. But yeah, if I can, yeah, I will also try to finish this one, right? And there is. Okay, scatter and histograms. Okay, yeah, let's see how things go. Let's see, right? Okay, yeah, um, so yeah, we are going to look into plots and to how to install plots. So let's say like okay, you are in your Julia prompt. Okay, so you just need to do add plots. Okay, I already did it and what to say had done it before, so it installed quite quick over here. But in reality, I don't know, depending on your speed of your computer or whatever it is, I don't know. Plots is very slow in Julia. So it might take very, very long. And before this computer, I was using an i3, Intel i3 or something like that. It was a good computer. Like most of the tasks could have been done. And that's one reason why I went to a Mac M1 because it's faster and all those stuff. Right. So, but yeah, like I would say use a Linux computer. Buying a Mac is a crime against humanity. Let me tell you again, right? So, okay. And if you want to know why, go to fsf.org. So, fsf.org, right? So, and I hope you will get it philosophy and what to say. And I am waiting for some kind of Linux on Mac once this 3 year what to say warranty is over. Like I will get this Mac on Linux because I don't think Apple will support no matter what. Okay, so that's the thing, right? So yeah, I just did this. I just went to package by pressing this what to say square bracket key. That is the right square bracket key. So that's what I just did, and all I did was add plots. Okay, so that's what I just did, and I got something, right? So that's the thing. So the plots had been installed for you. It could take long. It might be very long. So be patient, right? So now let's come back to the blog. Okay. So like okay, we have added plots and all those stuff. Okay, you can also do it like this one using PKG add plots. Okay. So like that's how also you can do. So now let me just start Jupyter notebook, rename it as plots. Okay, now I'll just do using plots. This is how you'll use packages in Julia, if I have not told before, right? So, okay, right. Sorry about all these things. Okay, right. Yeah. So, and what we'll just do is do a very simple pie plot. Okay. So, yeah, it's taking time. So you can just see it, right? So it just takes time. And yeah, because this one is a Mac M1, possibly one of the powerful, uh, what to say, laptops available. Yeah, this one worked faster. Okay, for you it might be really slow. So yeah, so what I'm just doing is like, okay, like I'm just putting a pie plot. I'm just representing my favorite plate or whatever it is. Like I want 60% of it to be mutton biryani. Mutton biryani is a dish like we eat in India and most of what to say the Middle East and all those stuff. Okay, so that's how it is, right? And another one is a tandoori chicken. Yeah, I encourage you if you're a Westerner, yeah, please go and Google it. Okay, so and then prawn roast and greens. This is how my plates to be. Okay, so I want 60% mutton biryani, 20% tandoori chicken, 10% prawn roast, and 10% greens. So that's how I would like my plate to be. And yeah, this one plotted, right? So that's it might look simple, but yeah, like while you're doing it might take time. So that's the thing, right? And possibly I think Julia is what to say, its version is increasing. So I think let me go to Julia language, right? So yeah, it's 161. Okay, it's still 161. Yeah. For me also it says 161. Okay, no problem. Okay, I think I have the latest, right? Okay, fine. Now let's see about okay, a basic plot function, right? Uh, why is this appearing? Right? So what we are just doing is like we are having theta, right? Theta can be represented as minus 2 pi to 2 pi, right? So, and this is actually what to say, range in Julia. So range means like, yeah, minus 2 pi to 2 pi. And we are going in steps of point not 1, right? So that's how it is. So yeah, this is where Julia really rocks. Okay, like so look how easy it is, like compared to other languages, right? So and it's fast, okay, right? So it is fast, and yeah, minus 2 pi is minus 6.28, and plus 2 pi is 6.27, and that's how it is, right? So it doesn't mean that all these ranges get stored like a very big number, minus 2 pi to plus 2 pi in increments of point not 1. No, not like that. It gets lazily evaluated. Only at the last minute it gets evaluated, therefore saving computer resources, right? So that's how it is, right? So, okay, yeah, let me just put this and explain it, okay? Okay, right? So, okay, this will give you a beautiful sine and cos plot, okay? So, if you see this is theta value, so this is the x-axis, okay? So, this is the theta x-axis, and we have put a x label that is like, okay, radians, so you can see radians over here, and y is amplitude, so here is the amplitude, right? So you know sine and cos, you should have been knowing, like if you have read max, sine and cos alternates between minus 1 and plus 1, so that's how it is, right? And we are putting labels over here. Okay, the blue label is sine theta. Of course, sine theta is 0 at 0, and cos theta is 1 at 0, so that's how it is. So we are just putting labels over here, and we are giving limits, like, okay, let it be like from what to say, y to be from plus 1.5 to minus 1.5, and x is x, let it be to minus 7 to plus 7. That's what we are just doing, because like this one is like what to say, like it is from minus 6.28 or something, right? So I just thought, okay, minus 7 to plus 7 means there'll be some kind of padding and it'll be good, right? Or I can just give it like, okay, minus 6.29 or something, so that like this thing will be very, what to say, touching this one or something like that, like this cos and sine function, it will be touching this one, right? So yeah, that's how I have just given. And if you look over here, what we are doing is sine dot of theta. Before, if you look in functions, we use this dot notation to get, what to say, each and every value we would like to get, right? So let me just put like something like, okay, like okay, sqrt of 4. Okay, so okay, we are getting 2. But now what if if I have an array like numbers? Okay, so now I just put like 1, 2, 3, 4, 5, and something like that. And I want to get SQRT of all numbers. So will this work? No, it won't work. So what I do is I just put a dot notation. It means do it on each and every element in that vector, right? So we are just getting it, right? So that's how it is. So over here sine theta means, okay, like you will get sine value of each and every theta. So this will increment in from minus 2 pi to plus pi in point not 1 steps. Okay, so so point not 1 means what? It's minus 628 to plus 627. So I don't know how much it is, like something so many steps. Okay, so it'll plus 1, because yeah, like 0 should also be counted, right? So minus that is like 628 into 2. So that's the number of steps are there. So 628 into 2, right? So 1256 steps. Okay, so it'll do sine theta in 4066 values, and this will do cos theta, right? Similar, because we are keeping the dot operator, right? So yeah, and that's how it is. So we have a sine and cos plot, and I am also explaining some other plots. Like, please don't limit with this one. Okay, right, yeah, yeah, yeah. Okay, yeah, this one is okay. What to say? Going big. Okay, okay, okay. So now, okay, now I'm just trying to explain something like what to say, like putting a plot, changing some more attributes, and then what to say, like what to say, changing this plot on the fly or something like that. Yeah, so that's how it is. So let's put a plot and store it in a variable p, right? So like that's what I'm just doing. And mostly I think this is self-explanatory. Okay, we are just this is theta. Theta has been defined over here, right? And sine of each element of theta. So that's what we are doing. Like sine dot. Okay, I'll call the dot for each element. Okay, color we are putting purple, right? Okay, so and line width we are putting 3. Okay, so this one I think line width is 1. Okay, by default. Okay, so if you're not giving something, it will take default. I think you can look at functions with default arguments in this videos to know how it is. And label, I'm just putting it as sine theta. Okay, so I just got a plot. Okay, so look, humans are very iterate, work very well, very iterative and small steps. So you plot a small step, okay, and now you want to make this plot more complex. Okay, so how to do this? So how to change this plot p? So you have what to say, capture this plot in this variable p. So how to change this p? Okay, so that's what we're just trying to do. Okay, so we can change it like this one. Look, you have seen functions with a bang. Functions with a bang or exclamation mark means you are changing something, right? Okay, so you are telling like, okay, plot, okay, with a bang, that means you are changing something. Now change this plot p, okay, and the x-axis should be theta, the y-axis should be cos of theta, and its color should be red, the line with 3, and label is cos theta, right? So that's how it is. So yeah, you're just getting it, right? Uh, so that's the thing, right? Now I'm once again changing it, okay, right? Now I'm giving x limits, y limits, okay, like let me see, like I'm just changing p once again, right? When this function goes very big, I like to give something like this rather than going all the way horizontal. I like to go vertical so that like it's more readable. That's what I feel. Your style might be different. The company you work with, the style might be different. It might depend on your boss or something like that, or your leader or something like that. Look, you can't argue with all these things, like, and uh, yeah, you can argue or you can't argue, so it all depends. So that's the thing. So I'm just giving this plot p a title like sine and cos plots. X label is radians, y label is amplitude. So yeah, it's almost similar to the plot we plotted before, right? And the only thing is like the line with the color and all we are controlling over here, right? So that's okay. That's the thing in this blog. Okay, yeah, I'll be putting all the blog links. What to say over here. And there is a thing called scatter plot. Okay, scatter plot means like you have like something like housing prices or something like that in the future that you can do with scatter plot. Okay, because if you put it as line or something, it won't go good. Okay, so like uh, okay, yeah. Let me just put something like this one, scatter plot. Okay. So yeah, I don't like this one. Okay, let me put like 7124 or something. 7134. Okay, right. Okay, right. 7154. Okay, right. Okay, right. So this is a scatter plot I've just done, right? So what? Okay, let me see what I've just done in this plot, right? Yeah, once again I'm just changing the scatter plot. Okay, I'm adding another plot over here, right? So this is the second plot I'm just adding. So this is the second x values. This is the second y values. I'm just putting color blue, right? Yeah, the first one is color red and next one is color blue, right? Okay, yeah. So the scatter is very similar to plot. Plot plots is line. Scatter plots something like scatters, like those dots, rather than connecting those dots with a line or something like that, right? And yeah, now I'm just changing. Okay, so now I'm just changing. What I'm just giving is like, okay, I'm just putting another x and new y values. Okay, right? And this one I want to give it as orange. And yeah, so over here you need to note the series type. Okay, so over here I'm using plot. Okay, because I think like you can't give scatter and change this. Okay, SCATTER. Let me just do that. Try to change that. Oh yeah, it's still working, right? Okay, so then there is no need to give. Okay. So yeah, you can do that. I'm sorry. Okay, so okay, let me do it from first. Okay, scatter plot. Okay, the second time you're giving another plot over here and making it blue. The third time you're giving another one. But yeah, and it is the color orange, right? Okay, but you can use so also use plot and say that the series type is scatter. Okay, so that also you can do. So let me put another one like orange. Okay, and let me put it as green. Uh, Green and okay, what? Let me put this as square. Okay, so 1, 4, 6. Okay, 9, 16. Right. So here I'm just using plot, but what I'm just doing is plot is a very generic function. Okay, and you can say like rather than just putting line, which is default, I just want series type scatter. So it'll do that, right? So that's how it is. So you just have this quadratic curve and all those stuff, and that's how it is. Yeah. So yeah. So yeah. Just getting something jumbled over here, right? And yeah. So over here, I'm just changing the limits over here. X should be like from 0 to, well, right? Okay. Yeah. This is 0. Okay. That's what I'm just doing over here. You can change the limits and all those things. Okay, and another type of plot we are just seeing is histogram, right? So, like, it's not very good idea to put random values in histogram, but yeah, that's how it is. Like, okay, okay, or uh, okay, like what to say, normal distribution in Julia. Okay, normal distribution. I just want to see what's the normal distribution and put that in histogram. So okay, I think this needs some other package. Okay, so like so yeah, I don't want to do this now because the load is bit the cognitive load for me is bit high right now if I do that. So I will do it later. But yeah, we are having histograms. Okay, so this is basic plotting. So the reason why I put plots over here is to go for the next stuff like say guessing a number with genetic algorithm. So we will be plotting some stuff for it, and at the end, I think. Okay, so and that's the reason. Or are we plotting or not? Yeah, we are plotting it. Yeah, we are plotting it. Yeah, so like we are plotting it, and we are using all these things like some of the tricks we are used in this plotting blogs. Okay, so that's the thing, right? So yeah, plots are very important because like humans are visual creatures. It's said that two-thirds of a brain is used to process visual data. So and we understand more better when we are doing it visually. In fact, like in this iris data set and all, like in fact, like in order to deduce, like, okay, uh, okay, there is a thing called flower called iris, and depending on its petal length, we can classify its species. Okay, so just by plotting it, I was able to see like what species it could be. Like, no need to even write complex machine learning functions for that. So, look, these are the three species that have been separated, and now I can just write my own algorithm rather than just relying on machine learning. So, data science is not like you are always relying on machine learning or artificial intelligence. First thing is you need to make sense of data. So that's data science. If you're unable to make sense of it, then you just give it to a machine learning, or what to say, a deep learning algorithm, and what to say, you just try to do it. So that's what data science is. So machine learning, AI, and all those things are subset of data science. Okay, data science is much more bigger. You need far more skill sets than just machine learning and all those things, right? So that's the thing. So this blog is about data science with Julia, and in that, yeah, we'll also be concentrating on machine learning and all those stuff. So that's how it is. I hope, yeah, this plotting was kind of useful to you. Thanks for watching. Bye.